Hello guys, my name is Lazaro and today we're going to be going over a hard LeetCode problem. This problem is called minimum window substring. Given two strings s and t, return the minimum window in s which will contain all the characters in t. If there is no such window in s that covers all characters in t, return the empty string. Note that if there is such a window, it is guaranteed that there will also be only one minimum window in S. So let's look at the examples to really understand this problem. Here they give us S, which is just a string of letters, of characters. And they also want T. What we want to find in S is a window or a substring that has every character in T. But the thing is, we want the minimum substring or the minimum window. For example, here, A, D, O, A, D, O, B, E, C, that includes A, B, and C. But that's not the right answer because the minimum window is B, A, C, B, A, and C. So that's what they want us to do. If we look here at the second example, it's the exact same thing. It's just that S is only one character and so is T. Now, if here S was, for example, B, and then T was A, then instead of returning B or A, we return an empty string because there is no such window. Cool. Now that we read the problem and we understand what it's asking us, let's get into the intuition of it and how to solve it. So right here, I wrote down the first example. We have S and we also have T. We're trying to find every character in T in S and try to find the minimum window of it inside of S. So let's try to logically think how we can solve this answer. We know we have to go through S, iterate through it, and try to find a window that includes every character in T. So how can we do that? Well, one way is to just do a nested for loop, which will give us big O of n squared. Let's see how that can work. First, we start off at A. Then once we're at A, we go over this string again in the second for loop, in the one that's nested, and we go over every single letter. Once we see or we find a string that has every letter in T, we stop and we record its length. For example, the outer loop is going to start at A. The inner loop is going to go from A all the way to the end until it finds every single one of these. So here's what the second loop is going to do. We already found A, so we can cross that one out. Now we're at D. D is not inside of T, so we still don't do anything, we continue. Then we're at O. O is not inside of T. And then we're at B. So now we have seen A and B. We can cross out B. But we still continue because we haven't found every single letter inside of T. E is not inside of T, we continue. And then we see C. C is inside of T, and we found every single character in T in S. This has a length of 6. So, or the output is going to be A, D, O, B, E, C. And we record this. Then we start over. Now the outer loop is going to be at D. And then the inner loop is going from D all the way down until it gets to this A. Because once it gets to this A, it has B, C, and A, which is all these again. Now obviously this length is much longer than this substring right here, so we don't overwrite it. We continue with this one because it's shorter. We continue doing this until we eventually get down here at the end where our outer loop is on B, and then our inner loop is going to go from A, N, and C Since this includes every single character in T, and this substring is indeed shorter than this one, then we overwrite it. And now our answer is going to be B, A, and C, which would be correct. But like I said in the beginning, this has a time complexity of big O n squared. And we can actually do better. So let's see how we can do better. First off, let me erase off this. You know what? Actually, we should probably go back. Perfect. So the way we can do better is if we use 2 pointers to keep track of where we're at, and then the other pointer is going to expand the window. But then once we have a window that contains every single character in T, then we can contract the window. This is called the sliding window algorithm. So let's visualize this. Let's say my first pointer, let me create a key down here, equals pointer 1. You know what? Let me actually call it a left pointer. That might help. And then let's make this one a right pointer. Perfect. So we're going to put our left pointer at 0. And then we're also going to put our right pointer at 0. So does this string right here, from our left to our right plus 1, and the reason I say plus 1 is because the right excludes. It's exclusive. So we have to add that 1 to get just A. So does this substring contain every character in T? It does not. Since it doesn't, we want to increment our right pointer. Does AD contain every single character in T? It doesn't. So we increment our right pointer again. O is not inside of T. We're incrementing one more time. B is inside of T, but we still have not found every single character inside of T. Because from here to here, we do have A and we do have B, but we don't have C. So we continue. Now we're on E, and it's the same thing. We still have not found C. Now, once we do get at C, we record this substring and we keep it on the side. So let's put it right here. A, D, O, B, E, and C. So this is where we're currently at. This window does have every character in T, but now we want to contract the window to see if we can get any smaller. So now let's move our pointer from A to D to see if we can get a smaller window. As you will see, we actually can't do this. Because once our left pointer moves from A to D, we no longer have A. Since we no longer have A, that means our contracting failed, and now we're going back to our right pointer and we're just going to increment that. Kind of regret making that square, but that's alright. Now our right pointer moves from C to O and is trying to find that A. O is now our A, so we continue. Still the same thing, we continue. Still the same thing, we continue. Still the same thing, and then we're here, where we have found the A. So now our current substring is all this. Because we have found A, we have found B, we actually found it twice here, and then we have found C. But as you will see, this substring is shorter than this one we have down here. I mean, it's longer than this one we have down here. So we don't overwrite it and we continue. Now, like I said before, we found a window, but let's see if we can get a smaller window by contracting it. So now we take our left pointer, we move it from D, and we move it to B. We still have every single character in T in the substring, as you can see. Because we do have A, we do have B, and we do have C. So let's continue. Let's see if we can get smaller. Now let's move to B. And this is still the case. And every time we're contracting this window, we're also comparing the size of this substring to the current smallest substring we have. Now this one is still larger than this one down here, so we don't overwrite it. Now we continue moving our left pointer. Now, from here to here, we still have our A right here, we still have our B, and we still have our C, so we can continue. And the substring is still larger than this one, so we don't overwrite it. Now we have a new substring. It's actually the exact same length as this one down here, but we only need to return one minimum window, so let's just not overwrite it. Now, let's contract one more time, because we still have every character in T. We still have the C, we still have the B, we still have the A. So let's continue contracting. Once we do the contraction one more time, you will see that we lost our C. We no longer have a C in here. We do have a B, and we do have an A, but no C. This means we have to go back to expanding our window. So we take our right pointer, and then we move it from our, oh, where was it actually? Okay, we move it from our A, and we move it to N. So we have B and A, but we still don't have a C, so we continue expanding. Now, once we move to C, we have B, A, and C, which is every character in T, meaning we can now contract our window. So we take our left pointer, move it from O to D, and we have a new substring. It includes B, A, and C, which is all in T, so we're fine. And it's the exact same length as this current one down here, so let's just not overwrite it. Now we move it from D to E. We still have our B, A, and C, so we can continue contracting, but the substring is shorter than this one down here. So now we can overwrite this. We can change that to E, B, A, N, and C. Now let's move our left pointer one more time. From E to B. We still have our B, A, and C. And this new substring right here is shorter. So now let's overwrite this one to B, A, N, and C. So let's move our left pointer again. Since we have every single character in T, we can continue contracting the window. So let's move it from B to A. As you can see, we have A and C, but we're missing B. So we have to go back to expanding our window. So we go from C to outside of the string. Once we're out of bounds, we know that we can no longer expand, and since we do not have every character in T, we know we're done. So what we're going to do is we're just going to return the smallest window we found, which is B, A, and C. And this is how we solve the problem. Now all we have to do is just implement this in code. So let's do it down below. Let me actually expand my canvas. There we go. Okay. So now let's write this exact logic out in code. The first thing we want to do is we want to make sure that our s and t are not empty, and also that the length of t the length of s is less than the length of t. Because if the length of t is greater than the length of s, then we know that we would never find that substring inside of s. Let me actually scroll up and show you guys. For example, this t down here if this was in ABC, let's say it was something else like not F, B, 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 E, D, A, N, N, N. This T is obviously longer than S. So we're never going to be able to find this inside of S since it's longer. It just doesn't make sense. So that's why we want to do the check. So right up here, what we want to write is if S is equals to an empty string, or T is equals to an empty string, or length of S is less than the length of T, then we cannot solve the question. So let's just return empty string. So if our search string is empty, or our T string is empty, we know we will never be able to solve the question. So let's just return. And then I already explained this part. So now to know if our current window size, the characters in our current window, if every single one of those characters is inside T, what we have to create is a hash map. A hash map is just a key value pair. So for example, if T was equal to A, B, C, then the hash map will be A is equal to 1 because there's one occurrence. And this key value pair could be set to anything, but in this case, I'm just going to set the key equal to the character and the value equal to the frequency, or the how many times that character has occurred. Then the B is going to be equal to 1 as well, and C is going to be equal to 1. And the reason why we want a hash map is because if we want to check if a character, let's say we want to check if B is inside the hash map, this time complexity is be O of 1, is be constant, is be super quick, which is exactly what we want for this question. Which actually reminds me that I never told you guys, but this logic up here, this time complexity, is be big O of n, which is way better than a big O of n squared. Okay, now that I explained that, we can continue. Okay, awesome. So let's create that hash map. I'm going to call it T underscore map. Yeah, let me call it this, T map. And then we want to know how many unique characters is inside our T string. The reason we want that is if our current window size, if our current substring if T has two A's, let's say this was A, B, C, A, then we want to know in our current window size if there is exactly two A's. If there's exactly two A's, then we know we have matched T once already. But since we're using the unique, since we're finding the unique characters, this will be equal to A, B, C, which will have a length of 3. So in our substring in S, once we have counted 3 matches, we know that our substring is equal to T. Well, not equal, but every character in that substring is inside of the T string. That might sound confusing, but once we work through the code, it will make sense. So that's our T hash map right here. And now let's just create that unique count. I'm going to call it cars or chars for the amount of unique characters. Now, to create our actual hash map, we need a for loop. So for char in T, so for every character inside the T string, if char is not in our T map, in our T hash map, then we want to add it and set it equal to 0. Then T map of that character is equal to 0. And since it's not in there, that means this is the first time we're seeing it. So this is going to count, this if block is going to count the unique characters only. It's only going to count it the first time we see it. So we can use that to increment chars. So we do chars plus equal 1. And then outside of this if block, we can change our T map, our value of that character in our hash map from 0 to 1. Perfect. And with this, we just created our T hash map. So for example, if our T was equal to B, C, A, B, then right now, after this for loop runs, our T map is going to be equal to B to C1, A1. There's 2 occurrences of B, 1 occurrence of C, and then 1 occurrence of A. And then our char, or unique character count, is going to be equal to 3. Because there's 3 unique characters, which we can also see if we look at the keys of this hash map. Okay, let me delete all of this and so we can continue. Now, we also want to keep a hash map for the S string. The reason we want to do this is so in our substring, in our current window, we can keep track of the characters and how many times we've seen it, so we can later compare. So it's almost exactly the same thing. We are going to want to do, it's going to be called S map as well. So similar names. And we're also going to be using a for loop. But for the S string, we don't care about the unique number of characters. So here, we do not create a chars variable. Instead, we just get right into the for loop. So for each character in S, if the character is not in the hash map, then what we want to do is we want to set S map of the character equal to 0. And that's it. We want to stop here. We do not want to increment it because we're going to be using this hash map for our Windows substring only. So we will fill up this hash map once we're going through that Windows substring. Awesome. So a couple of the variables we want is we want to have matches. We want to set that equal to 0. This will keep track of how many matches our current Windows substring has compared to our T string. So if matches, let's say if matches was equal to 3 and matches is equal to characters, which we created right up here, as you can see right here, then we know that our substring has every character in T, because these two are equal to each other. Perfect. So let's continue. Something else we want to keep track of is where that minimum window is at. So we want the left and right index of that minimum window so we can return the substring of that minimum window later on. So let's create those variables as well. So min left, whoops, is equal to 0. And the max right is equal to length of s plus 1. And you will see why we did the plus 1 later. Now we want to initialize our 2 pointers. I'm just going to call these 2 pointers I is equal to 0, and then j, and j is equal to 0. So I is basically our left and j is our right. And now we want to get into iterating our S string. We do that with a while loop. So while I is less than the length of S, we want to do a couple of checks. The first check is if we have not found every single character in T in our current window substring. So since matches is going to be keeping a track of if we have every character in T, what we want to do is if matches is less than chars. If this is the case, then we want to go inside this block and we want to do another if. In here, we want to do if j is equal to the length of s. Here, length of s is basically how we talk about right here, when it's outside of the bounds. If it's outside of the bounds, then we know we're done, and let's just return the current minimum window substring that we saw when we were iterating through the string. Now guys, should have said this a little bit earlier, but this is pseudocode. It might look a lot like Python, but to be honest, basically the same thing. And I do code in Python, so that is my natural language. So, you know, for example, here when I'm writing length, this is how you do it in Python. But all right, let's carry on. If j is out of bounds in the s string, we know that we're done. So let's just break here. Let's break this while loop, and we'll take care of this later, because outside of the while loop is where we're going to return on our answer. But let's say this if block doesn't run. If this is not the case, then we want to continue. We want to keep track in our S string hash map the current value we're at. So S of j is the current character we're looking at j. J is equal to 0 right here. So if, for example, our S was this S up here, S of 0 is going to be A. Because that's the character at index 0. And we want to add that character to our hash map. So in our hash map, we have seen the character A. We want to increment it from 0 to 1. So what we do is plus equal 1. So we've seen A once. Now we want to know the if block. If the current character we're at, which is that A in our example, if it's inside our T map, our T hash map, and our S hash map has the same number of occurrences of A, has the same number of occurrences as our T map of A, then we know that we want to increment our match. So matches plus equal 1. This is, so let's go over this. Let's say S was equal to A, C, D, B. And then T was equal to A. A, B, there we go. J is 0, so J's will be right here. So S of J is going to be equal to A, the character at index 0. Now in our hash map, we're going to increment our A frequency by 1. It goes from 0 to 1. And now if that A is inside our T map, in our T map, that is going to be the case. This is how our T map would look for this T string. If A is inside our T map, that it is, and the number of occurrences of A in our substring window is equal to the number of occurrences of A in our T map. In this case, it is, because A we've seen 1 in our current window, and in T map, A is 1. If this is the case, then we found one match. So we want to increment that match. So this is what that if block is doing. Perfect. And then outside of this if block, we can just increment J plus 1. But this is, for this if block, that's if matches is less than characters. What if that's not the case? If that's not the case, let's say if matches is greater than or equal to, in this case, we're going to take care of the greater than or equal to part. If this is not the case, we want to do an else here. Remember that if it's equal to or greater than, then now we want to contract our window. We want to try to find the minimum window that has every character of T inside of our substring of S. So now this else block right here is going to be taking care of the contraction part. We do that like this. So S of map, S map, which is our hash map of our current window substring. What we want to do here is our I, remember our I is our left pointer. And if you remember all the way up here, we were contracting our left pointer. So the character at our left pointer, we want to subtract 1 from it. Since we're pushing that left character up, we want to remove the occurrence of that left character. I'm sorry, if we're pushing our left pointer up by 1, then the character currently our left pointer, we're no longer going to have in our window size. So we want to decrement it. Now, if the character at our left is inside of our T map and our S map, the value of our S map at S of I is equal to T map of that character, of the S of I character, minus 1, they won't want to decrease matches. What this is saying is, if the character that we're now losing, if it's inside our T map, and now our updated S map, which has 1 less of occurrence of that character, if it's equal to T map of that character minus 1, it means that we do not satisfy all the conditions in T, because we have lost a character that we needed before. So for example, if our if S was A, B, C, and T was A, B, and we're moving our left pointer from A to B, then we're losing our A occurrence by 1. In our A is going to go from 1 to 0 in our S map. And then our T map, we have our A set to 1. So we do want that A. But we just lost that A, so now we have to decrease matches, because we have lost a match. Perfect. And now, since we're contracting that window, we want to increase I plus equal to 1. Now, after this else, we want to now do an if, checking if matches is equal to characters. So if matches is equal to characters, then what we want to do is, since remember we have right here our min left and min right, we want to check if the current substring window we have is less than that min left and min right. So if j minus I minus 1, the reason we're doing minus 1 is because in this if block right here, we're incrementing j. So we're going, if our S was A, C, B, our j is going to start here, and by the time this finishes, it's going to be at C. So, and then we might have a match that includes this string right here, but our left is at C. We also want to include the A, so we have to do an extra minus 1. So let's do that. That's exactly why we did that right here. If this calculation is less than our max right minus our min left, then we know we have a smaller window substring. So we set our min left equal to I and our max right equal to j minus 1, because we want to include the character before. And this is a whole while loop. This is all the logic we want inside our while loop. Taking care of expanding the window, then taking care of contracting the window, and then taking care of recording the the minimum window size. This is every single thing that our while loop is doing. Now, of course, outside of this while loop, we want to check if max right minus min left, if this is greater than the length of s, then we know we did not find a minimum substring inside of string s. So we return an empty string. This is exactly why up here I did length of s plus 1. This calculation is going to say the max right minus min left is going to be greater than the length of s, and that's impossible. So this is basically telling us that since it's impossible, we know to return an empty string. Else, if this is not the case, then what we want to return is a substring of s from the start of min left all the way to the max right. Plus 1, and the reason I'm doing plus 1 is because this substring slicing right here, it excludes this this value. So to do plus 1, it goes all the way to max right. And this is our logic. I know it's a lot, but this is our whole logic right here. So now let's actually write the code in Python and solve the question. Oh, I'm actually gonna delete everything. There we go. So now let's do that checking if s is equal to an empty string, or t is equal to an empty string, or the length of s is less than the length of t. We know this is going to be impossible, so let's just return empty string. Now let's create our hash maps. T map is equal to an empty hash map at first, and characters, which would be the unique character count in t, is going to be set to 0. Now, for every character in t, if we have not seen that character before, then let's add it to our hash map and set it equal to 0, and let's also increment our cars count. From there, we want to increase our hash map value of character from 0, and we want to add 1 to it, so we can keep track of the frequency. Now we want to do the same thing for our s hash map, which will be keeping track of the values inside our current window. Now for character in s, if that character is not in our s hash map, then let's just add it and set it equal to 0. Now let's also write our other two variables, which is matches, and then min left and max right, set it equal to 0 and the length of s plus 1, so we can do that check later on after our while loop. Now we want our 2 pointers, I and j, and now we can actually get into our while loop. So while I is less than the length of s, since while our left pointer is less than the length of s, let's iterate through this s string. If matches is less than cars, and now here we want to check if j is equal to the length of s, aka it's out of bounds, let's break. That's not the case, then let's add the current character at j to our hash map, and it's incremented by 1. Well, we're not adding it because it's already added right here, but let's just increment it by 1. Now, if S of j is in our T map, and the occurrence of that character in our S map at j, if this is equal to the occurrence of that character in our T map, then we want to increment matches by 1. And then finally we want to increment j. Else, if this is not the case, we want to contract the window by decreasing that occurrence. But if this character is in our T map and it's less than if this character that we just decreased, if it's equal to the occurrence in our T map of that character minus 1, then we know that we had a character that we needed and we decreased it. So we're losing a match. And then we can just continue contracting by increasing I. Then finally, we want to check if matches is equal to characters. If this is the case, then we want to see if our substring, our window size, is smaller than our current one. And that's the case, let's just record it. And that's the whole while loop. Outside of this while loop, we want to check if our current window size is actually smaller than the length. We want to check if it's bigger than the length of S. If it's bigger than the length of S, then we know we never found a valid window size, and let's just return an empty string. Else, let's actually return the substring from the left pointer all the way to the right pointer plus 1, because like I said, it's exclusive. Now, I wrote that pretty quick. Let's see if there's any typos. Let's run it. All right, and there is a typo. Perfect. So if it's in tmap, it's equals. Oh, here it is. Too many brackets on that. So let's run it one more time. And it runs perfect. Now let's submit it. See if it works. And it does. It got accepted. Perfect. So thank you guys for watching. If you did enjoy this, then make sure to, as you see, I did it multiple times on here. Make sure to join our Discord channel. We send out beginner and advanced problems like this every single day. So it's a great way for you to become a better programmer and to just learn. Other than that, I want to thank you guys for watching. I know this was a long video, but hopefully it helped you guys on solving this question. And yeah, have a nice day, guys. Thank you.